Why are simple machines never 100% efficient? Imagine trying to push a heavy box up a ramp. You might think all your effort goes into moving the box, but in reality, some of that energy is lost along the way. That's because simple machines like levers, pulleys, and inclined planes are never perfectly efficient. They help us do work more easily, but they don't do it without losing some energy. The main reason is friction. When parts of a simple machine move against each other, they create resistance. For example, when a pulley wheel turns, the rope rubbing on the wheel causes friction. This friction turns some of your input energy into heat, which is energy that doesn't help move the object. The same thing happens with levers and inclined planes where surfaces contact each other. No surface is perfectly smooth, so some energy is always lost overcoming this resistance. Another factor is deformation. When you apply force to a machine, some parts bend or slightly change shape. This bending absorbs energy that could have been used to do work. Think of a metal rod that slightly bends under pressure. Part of your effort goes into that bending instead of moving the load. Vibrations and sound also waste some energy during operation. When a machine makes noise or vibrates, energy is escaping as sound waves, which again don't help move the object. Because of these unavoidable energy losses, the output work from a simple machine is always less than the input work. Efficiency is calculated by dividing the useful work done by the effort you put in and then multiplying by 100 to get a percentage. Since some energy is always lost, this percentage can never reach 100. For example, an inclined plane might be 80% efficient, meaning 20% of your effort is lost mainly to friction. Even though they are not perfectly efficient, simple machines still give us a big advantage. They allow us to apply less force by increasing the distance over which we apply that force. This trade-off makes tasks easier and faster. For example, a pulley system might requiring less effort to lift a heavy object, even if some energy is lost along the way. Understanding why simple machines are not 100% efficient helps us see why tools need maintenance, like lubrication, to reduce friction. It also reminds us that energy cannot be created or destroyed, only transformed. Some of that energy always turns into heat, sound, or deformation, which is why no machine can be perfectly efficient. But even with these losses, simple machines are still incredibly useful because they make work easier and more manageable in everyday life.